In this video, we're presenting RPBG, which make neural point-based graphics more robust against diverse scenes in the wild. The work is done jointly by researchers from the University of Tokyo, Huawei Technologies, Peking University, and X-Ray. As one of the most well-known milestones of using point as the proxy for novel view synthesis, MPBG performs neural re-rendering upon 3D point clouds by fitting neural descriptors bounded and a neural renderer in an end-to-end manner. Under the paradigm by MPBG, we aim to boost the robustness of such baseline under more generic conditions. Specifically, we employ off-the-shelf structure from motion and multi-view stereo methods that have been tested by time to obtain the point proxy. To alleviate the issue of patchy points and messy occlusion, we leverage stronger image restoration networks to perform neural rendering upon the imperfect rasterization. We also retargeting image-wise loss functions for image reconstruction to improve the perceptual quality of re-renderings. As a result, the great potential of such paradigm has been stimulated in terms of robustness, perceptual quality, and ease of scaling up and removal of transient objects. We are going to shed some light on the effectiveness of point-based novel view synthesis. To have a general idea how diverse the real data can be, we here give several examples. These datasets vary regarding the shoot trajectories, some taken under a smooth movement while some with a free trajectory. The view densities could also have a huge impact, since the redundancy of input views is critical for novel view synthesis. The indoor scenes are usually bounded, but the outdoor scenes are unbounded. And of course, the scales of the target scenes can also be diverse. Therefore, for a general case, it's basically how it works. We first capture the scene and then use tools like CoMap to calibrate the camera parameters. And based on the knowledge of the scene type, we adopt the most suitable parameterization of radiance field, which is to say, apply the most suitable kind of nerve variant to represent the target scene. With the assumption made, we can finally optimize the radiance field. As you can imagine, the procedure of choosing a suitable parameterization requires experience-based knowledge, and the choice can directly make the fitting easy or not, even possible or not. This is tricky in practice and undesired for beginners and custom data. As we have mentioned before, novel view synthesis heavily relies on the rich covisibility information across multi-view images. Most of the failure roots in the lack of reliable covisibility, including sparse views or noisy post-estimation. However, we find that triangulation methods are quite robust in this aspect. They are either designed or tuned to work under these imperfect conditions, so the robustness can be somehow guaranteed. They are able to get a fair enough reconstruction of small objects, indoor rooms, outdoor parks, and even block-wise areas, with one set of scene parameterization and one method. But sometimes the point can be patchy, so we need to further take care of that. We notice that the task formulation of the neural rendering process in MPBG is quite similar to the well-studied task of image restoration. Both of the tasks require us to adaptively identify the degradation pattern, like the rain and the void in the given case, and then append the contents at these regions. So we make an ablation study regarding different well-known image restoration backbones, and it turns out that all of the methods can get a pretty good re-rendering results. Here is a visualized comparison of our method against other SOTA methods. It was noting that we are using an image-wise perceptual loss for training, so the overall appearance of the result of RPBG can be more pleasing without sharp artifacts that are trained with local pixels only. With the paradigm of point-based neural re-rendering, RPBG also enables such features that can be interesting and useful in actual applications. For example, the editing of scene can be done by simply editing the point cloud, but a strong impending ability and a good editability are contradictory in some way. and the scalability can be achieved trivially without any data partition. Triangulation method usually assume a static scene, so the transient objects are not reconstructed. It makes the removal of transient objects very simple, without any pre-processing like semantic segmentation. To restate, we propose RPBG as a general solution for naval view synthesis in the wired. It is robust to different scene types and to the noise in data as well. But we notice that when the triangulation is very sparse, the temporal consistency of such paradigm can be unsatisfactory, so there is a trade-off between per-image quality and video stability if you want to render consecutive frames. There are more interesting discussions in the supplementary of our paper, and thank you for your watching.